Hi guys, so in this video I'm going to show you how to do linear and non-linear regression. So the example that I will show you here is taken from one of my past works. I think this is from 2022. And so we had some data points like this. So in the what is there on the y and the x-axis is not important. So we had this kind of trend. And when we have this kind of trend, it's difficult to really fit into one standard function. So this is the data that we had. And when we paste it in this regressiontool.com, then we have its plot, but because the default function and the default initial parameters, they are also creating this other plot. That's why we cannot really see it. So I think first we need to remove it. Yeah. Oh, okay. So now we can see the shape of the data points. And it's a quite a strange kind of trend, right? So does not fit into a simple exponential decay. So if you already have a predetermined model, then you don't have any other option but to fit your model into these data points. But in our case, because we did not have a phenomenological model, so that's why we thought, okay, we can just go for a completely empirical model. So in that case, we just have to find a function that really nicely fits to this trend. So how to really do that? So the first thing is to observe the trend. So first we can see, okay, this is going down exponentially. So probably an exponential decay function would nicely fit, at least in this part of the function. But then it has this kind of rise and then fall again. So what is a function that looks similar to this? So what we thought, okay, maybe the Gaussian kind of plot can be useful here, because the Gaussian, the bell curve, it goes and it forms this kind of bell kind of shape, and it goes up and goes down again. So maybe we thought that combining the exponential decay with a Gaussian function might be might work in this case, and that's why we thought, okay, maybe this kind of function. So I already have it on my Excel. So this is the function that we first thought of, and it also worked, so we did not have to do more modification. So this part is the exponential decay, and here this is basically similar to a Gaussian distribution function, and here we have C5 that's constant, and that will be needed for so that this graph it takes constant values after a certain value of x. Okay, we don't see the comparison here because with these initial parameters, it's completely off. Maybe we should first make it all zero. Maybe it will be easier. Okay, so all the initial parameters are zero now, and we need to first start with something. So it's very important in nonlinear regression, especially with the standard LM algorithm. It is important to have some decent guesses, because otherwise it will not really give nice parameter values. It will not converge. It's very important because with linear regression, if this was a simple linear function like mx plus c, like c1x plus c2 or something like that, then it would not need much thoughtful initialization. It does not need, because almost all the time it will nicely converge and do a nice fitting. But when we have this kind of complex function with this kind of complex data, we need to be more careful. Okay, so these are all zero. So let's start this C1 with 1. How does it look? Okay, it does not do anything bad. It's this initial plot is going closer to the data points. Maybe we can go for 4 or maybe a 10. It's not bad because at least we have something that is at least intersecting with the data points, right? So C2, maybe 1. Again, it goes down, so maybe -1. What does it do with -1? No, it gives a completely weird shape. Maybe 4. No, because still has big difference. So maybe 0.01. Yeah, it's better because now we can see that it has this decay kind of shape. Maybe 0.5? No. Maybe 0.01? Probably it's a good guess. Okay, maybe C2. Okay, C2 brings it closer. Maybe I will go for a value 5 or something. Maybe 6. Who knows? Yeah. C4. C4 is in exponents, so it will be very sensitive. We have to be careful with this one. So 1. Okay, see, it really completely blows off. 10. Okay, it's not even possible. -1. Not bad. -10. Does not do much. -2. -3. Okay, it just keeps on. Maybe 0.001. No. Maybe I'll just go for a very small value. 0. Okay, maybe I will just keep it 0 because there's not really too much, right? And C5, I think C5 maybe something close to here. Maybe I will take maybe 7. Or 7 is too much. 5. Okay. Maybe 10, I will make it 20. Yeah. Now it looks like it's not really following the shape, but at least both the graphs are there. And probably it will give us a good regression result. Let's check it out. It's optimizing. And it has done it quite well because now we can see this is the optimized fit after with the model. So it's really fitting quite okay, I would say. And the R square, R, and the adjusted R square, they are all acceptable. They're good enough to report. So this is how you can do nonlinear regression on the regressiontool.com. So what is really important here is really the initialization because and which is also not that difficult actually. So make everything 0, 0, 0, 0, 0, everything 0, and then you start with the first parameter, play with it, and then see where it is going. And if it is completely blown off, then just don't use that kind of value because that's a sign that the algorithm is not going to converge. So in that case, you are not going to get nice fitting. So this is the end of this video. I hope you find it useful, and you can write to me if you have any further questions. Bye-bye.